This is Algebra 1, Lesson 3.4. It's found on pages 151 to 156 in your textbook, and the lesson today is about solving equations with variables on both sides. The cheetah is the fastest animal on land for running short distances, and later you're going to do a few problems in solving an equation to find out if a cheetah could catch up with a gazelle. I don't know, what do you think? Now we're going to talk about collecting variables on the left side, and the first problem we have is going to be 7x plus 19 equals negative 2x plus 55. But before we get started, we need to talk about what a coefficient is. And so a coefficient, so if I have the equation of negative x plus 3x squared, what I really have is negative 1x plus 3x squared. You can just automatically, if it's easier for you, just write that 1 in there. It's always there. If it's not, doesn't show. And if you look at which one is the coefficient here, the 1 is the coefficient and the 3 is the coefficient. So that's what the coefficient means. That was just a review from one of the lessons in Chapter 2. Now what we want to do if we're looking at the problem up here is to we want to work with the side that has the larger coefficient. So the larger coefficient, and again the coefficient is going to be the number with the x. We have 7x right here and negative 2x here. So the larger coefficient is going to be the 7 here. And so we want to get the terms on the left side where the 7 is, and then the result will be a positive coefficient. So instead of, if we went the other way and got it on the right side, we would have a negative. So we want them on the left side for this. So since we want to get all the variables on one side, numbers on the other side, we want to, we're going to have 7x plus 19 plus 2x, because that's the opposite of that, and then we will end up with 55, and then by the time I write, it really would be, I don't have enough room here, we'd be adding just on this side right here, that these two would cancel each other out. So you're just going to be left with 55. So by the time I add the positive 2x to both sides, then it just leaves me with the 55 on this side. So I took a shortcut here. Now we can regroup them just to make it easier. Okay. And then I can keep combining like terms. Now I want to get the 19 on the other side, so I'm going to take away 19. And now I have 9x equals 36. Now I want to divide each side by 9 to get, so I have down just to the x, and I will have x equals 4. And then if I plug that back in, I can test to see if that would work. And our answer would come out, if you work that out, to 47 equals 47. When you're doing your homework, you're going to have to look and see if you had, let's say, the same coefficient on both the left side and the right side, except one was positive and one was negative. You want to work out the problem so that you're not going to end up with the negative answer. So sometimes you have to sort of toy around with the problem a little bit to see which one is the better one when they match up. Okay, so if you have a question about this, or let me know. For the record, there is a dog on one of the news programs, and my dog is panting loudly, and there's nothing I can do about it. Okay, so now we want to look at collecting variables on the right side. Let's say the problem says solve 80 minus 9y equals 6y. Just a hint to remember that 80 minus 9y is the same as 80 plus, and in parentheses, minus or negative 9y. So if we just, looking at that, rewrite our equation here. Now we can see that 6 is bigger than 9y, because if you did it on a number line, 6 is on the right side and the negative 9 is on the left side, and so the 6 is bigger, and so we're going to collect our y terms on the right side because that's the bigger number, and that way we will get a positive coefficient. So let's work this out. The first thing we want to do is to add 9y to both sides, and we get 80. Oh, sorry. We get 80. These. Oh, sorry. I can't get my pen to work. 80 equals, and then we can add it over here, and so we have 80 equals 15y. We can get rid of the 15, divide both sides by 15, and we end up with 16 over 3 equals y. Now, you could go ahead and change this into, let's see, so 3 goes in 16, we'd have 5 over 1/3. So the solution is either one of these. This is a little bit easier to understand or to look at, but both of those would be the answer. So let's look at some examples. In our first example, we have 34 minus 3x equals 4x. And automatically we can see that 14x is the bigger side, so has a larger coefficient, so we will get rid of the 3x, and we are left here with 34 equals 17x, and we will divide both sides by 17, and we will get 2 equals x. And as always, even though I'm not doing it here, always go back and check and plug it back in and make sure that it works. Our second example here is 5y minus 2 equals y plus 10. And we can see that we could rewrite this just to eliminate confusion. Oh, sorry, I didn't. To be plus negative 2 equals 1y plus 10. We can see that the left side has the bigger coefficient, so we will get rid of the one over here, and that leaves us with 5y plus negative y plus negative 2. Equal sign, that is eliminated, so we just have the 10. Now we have 4y plus negative 2 equals 10. We will eliminate the 2. And now we have 4y equals 12. We will divide by 4, and we will end up with y equals 3. Plug that back in to your problem and see if it works. And it should end up with 13 equals 13. So number 3 is negative 6x plus 4 equals negative 8x. Now this is one of those that seems maybe to be contrary to what I said earlier. So on this one, we're going to do negative 8x plus 8x. We're going to just get rid of everything on this side. And we will let's see. Didn't do that very neat. Oh. Okay. And now we have 0 over here. We're going to have 2x plus 4 on this side. We're going to get rid of the 4 here. Now we have 2x equals negative 4. We're going to divide by 2 here, and we end up with x equals negative 2. You can play around with them when you do that, but this was the way that I would do this one. We still ended up with the negative, but there wasn't any real way to not have that this time. Always go through and again check your answers and see if it works out. So we have 3x minus 10 plus 4x equals 5x minus 7. We will get rid of the 4x here. Let's see. So first thing we want to do is combine like terms on each side. There's nothing to combine over here. But we do have 3x and 4x on this side, so we end up with 7x minus 10. So now we've combined those two terms. Now we can get rid of the, that's my dog, over here. So these two cancel each other out. We add that over here to this equation. Now we can subtract the negative 5x from the 7x. We're going to end up with 2x minus 10. We only have a 7 on this other side. Now we need to get rid of the 10. So we will add a 10 over here. These two are gone. That leaves 2x equals negative 7 plus 3. That's going to give us plus 10 equals 3. We're going to divide by 2, and that gives us 3 over 2, or 1 1/2. So what we've covered so far is collecting variables on the left side, so we end up with a positive coefficient, collecting variables on the right side for the same reason, and combining like terms first. So here's a sample problem. We have 5x minus 3x plus 4 equals 3x plus 8. First thing I want to do is to combine terms wherever I can. So I have 2x here plus 4 equals 3x plus 8. Now I'm going to, my largest coefficient is over here, so I'm going to get rid of the 2x on this side. Now I'm left with 4 on this side and 1x plus 8 on this side. Now I can take away the 8 here, and I would have 4 minus 8. I'm left with, and then let me rewrite that better here, equals x. I will add the 8 to this side, and to this side I'm left with 4 equals x. And actually that's a negative 4 because that was negative there. And it's negative x plus 4. Now let's look at solving this, and I'm going to have to go to another screen to do that, so hang on. So I've written my original problem, and now I'm going to plug in my negative 4. I will rewrite this for you in just a second. I just want to make sure I get them all there. So this would be negative 4, 3 times negative 4 plus 4, 3 times negative 4 plus 8. And because we're testing this out, we would actually have a little question mark above the equal sign because we are checking our answer here. So right now I can work this out. This is 20. This is actually going to be negative 20 plus positive 12. Negative times a negative plus 4. We have a negative 12 here plus 8. And when I combine my like terms here, I end up with negative 4. Negative 20 plus 16 is negative 4 on this side. And over here it is likewise negative 12 plus 8 is going to be 4. So this checks out. My solution is correct. So here we have 6x plus 3 equals 8 plus 7x plus 2x. The first thing we want to do is combine like terms. So we would end up with 9x on this side, and nothing happens on the left side. We can get rid of the 6x on this side because the larger coefficient is over there. These two are crossed out, which is why I put them on top of each other there. We end up with 3, and over here we end up with 8 plus 3x. Now we need to get rid of the 8 here. Plus 8 equals plus 11. Oh, sorry, I wrote that wrong. It's a negative. It's a negative. And so my answer is negative 5 equals 3x. We need to get rid of the 3. And now we have negative 5 over 3 equals x. I know that looks really, really strange. Now I have going to check my answer. I rewrote the original equation there. I plugged in everywhere where there was an x my answer, which was negative 5/3. Alright, so this may look a little panicky at this point, so I'm going to rewrite this so you can see what needs to happen here. And I'm writing it, and then I will talk. Let me just get it written here. So we have to multiply all of this out here. And so the first, let me get a different color pen. So the first one, right there, I don't even know how I did that little funny little yellow thing there, but that's okay. We will multiply this, and now we have 30 over 3 plus 3. We have 8 plus, and this one, let's see if I can do that again. Ooh, I did. Okay. 8 plus 7 times 1, oh, if I could write this correctly, is going to be 35 over 3. Plus, this is 2 times 5, 10 over 3. We're going to come back over here real quick because this will turn right here is 10 plus 3. And over here we have 8 plus 45 over 3. And something went wrong here. This is a negative. Okay, that's a negative. And this over here was a negative because we were working with negatives there and there. So that's easy to get distracted and to forget where the negatives go. Now we continue solving. We have negative 7. I forgot all my little question marks here because we were checking it. And over here we have 45 over 3 is 8 minus 15. And that works out to be negative 7 equals negative 7. So I haven't checked every problem we've done, but I'm trying to sort of pick the ones that look difficult so that it doesn't take so much time. Now, so far we've worked with linear equations that have one solution, and that would be right there. But you can also have equations that have no solution, meaning you could work it out and it does not equal when you plug it back in and you check it, it doesn't work out. And then there is another term that we haven't talked about, which is called identity, which means there's infinite number of solutions. And you can see over here in this work, there's multiple ones that you could come up with and that would check out. So we're going to look at some of them. With this problem, we have 3 times x plus 2 equals 3x plus 6. So this was we wrote the original equation down. Now we will use the distributive property here to get 3x right here, and then plus 6. And we'll have 3x plus 6 over here. We will subtract 3x from both sides. That crosses those out. We end up with 6 equals 6. In this case, the equation 6 equals 6 is always true. There's no question about that. So all values of x are solutions. And this is called an identity. Let's try another one. We have 3 x, oh, sorry, so we'll use the distributive, if this will erase, we'll use the distributive property here to work this out. So we end up with 3x plus 6. Sorry about my dog, you can hear him panting in the background. Now we're going to get rid of 3x on both sides. We end up with 6 equals 4. My dog wants me to turn the TV on, that's why he is panting so hard. And we can clearly see here that 6 does not equal 4, so this is no solution. So let's look at one more. 3x plus 2 equals 2x plus 4. Once again, we use the distributive property, and we end up with 3x plus 2 equals 2x plus 4. We can get rid of the subtract 2x from both sides. We will end up with 1x over here plus 2 equals 4. Alright, sorry, I made a mistake here worrying about my dog. This should have been 6. Forgot to distribute that. So we would have, that would be 6 right there. And now we can subtract 6 from both sides. And that will be, end up with as x equals negative 2. And this answer has one solution. So just to recap, x equals 1 is going to be an example of one solution. X could equals 4, but there's one solution for x. If it's 4 equals 4, or 15 equals 15, or you had some elaborate equation on both sides, it's true. It's true because this equals that, this equals that, this equals that. And we'll talk more about this later. And then if we had this one, well, 3 does not equal 7, so this is just not a solution. So those are your 3 choices so far.